Hello and welcome to Chapter 9, Developing the Sampling Plan. One of the things I want to get clear right from the get-go is the difference between a census and a sample. Ironically, 2020 is the year of the U.S. Census. U.S. Census is taken every 10 years. But a census accounts for everyone in a population. So when the U.S. Census goes out, they count every person, or attempt to count every person that resides in the United States. It's obviously a very arduous task that takes months to complete. Of course, there's some error in it. It's almost impossible to count everybody, but they do a pretty good job. And their attempt, obviously, is to count everyone. So a census counts everyone in a population. Now, the population may not be the entire population of the United States. You may only want to look at or question or find something out about a smaller population. Maybe it's everyone that lives in Fairmont, or maybe it's everyone that lives in one of the dorms at Fairmont State. But whatever that population is, it's everyone. That's a census. A sample takes a subset of a population, questions it, tries to find something out about it, and use those answers or that information to apply to the entire population. So that's what we're talking about in Chapter 9 is taking a sample and creating a sampling. So let's take a look at this. Here are the learning objectives for the chapter. There are 6 primary steps for drawing a sample, and they're listed here. So let's take a look at each one of these steps. Obviously, the first step is to define the target population. So a minute ago, I talked about everyone that lives in a dorm. So let's just think of one of the dorms on the campus of Fairmont State University, and we want to question, or we want to find out the satisfaction level of the people in that dorm. In other words, satisfaction with the dorm itself, their living arrangements, their living quarters. We could, but if that's what we want to find out, then obviously the population would be the people who live in the dorm, or the people possibly who lived in the dorm last semester or the last 2 semesters. We might include them as well. But we know the population. That's the population. Obviously, if we wanted to find out the satisfaction level of one of the dorms, we wouldn't define the population of commuters, because commuters don't live in dorms. So we have to define the target population to find out, in order to find out the information that we're looking for. Now, that's a very simplified example, but nevertheless, defining that target population is the very first step in the sampling, in drawing a sample. Now, I just mentioned that a population is everyone in that group. So the U.S. population, if you ask them a question, each one of them, you would be conducting a census where you're actually looking at everyone. The population of the dorm question would be everyone who has lived in the dorm, either past or present. Okay, so we have to really be clear in how we're defining that population. Now, in this example here, they say that the target population are households in the city limits of Sacramento, California, with 1 or more children under the age of 18 living at home. It's a very precise, precisely defined target population. Now, perhaps out of this population, they want to ask or find out something about the educational opportunities for school-age children in Sacramento. And so that might be a good target population for finding out that type of information. So one of the things that we have to discriminate against is a parameter and a statistic. A parameter is a measure of the population. So if we were conducting a census, we're actually finding out parameters. Maybe it's everyone under the age of 18 that resides in the United States. Well, a census, since we attempt to look at every single person, that would be a parameter. That measurement, that number of people in that classification would be a parameter. That measurement, because it's looking at the entire population. However, if we only looked at a subset of the population to try and determine how many people are under the age of 18 that live in the United States, that would be a statistic, because a statistic in marketing research terms is a characteristic or a measure of the entire sample, not the entire population. Okay, so these are calculated from the sample data, and they're used to estimate the population parameters. So in other words, if we want to make some type of inference about the population from the sample, we'll use statistics. So perhaps if we go back to that Sacramento, California situation, where we're interviewing households with one or more children under the age of 18 living in that household, we may, and I'm just throwing this number out there hypothetically, I don't know how many people live in Sacramento, California. It's a fairly large city. It's the capital of California. But Sacramento, let's say we go out and we interview 100 households with those with the stipulation of one or more children under the age of 18 living in that household. That would be a sample. That 100 households would be a sample. Now, obviously, we could get that information much quicker than if we would try to interview or survey every single household in Sacramento with one or more children under the age of 18 in that household. Okay, so whatever we derive from that, if it was statistically significant, we could infer that information to be true to the entire population, or the same as a census, if that makes sense to you. So obviously in marketing research, we try to look at statistics because we don't have the luxury of being able to survey everyone from a population. Even a smaller population, like Sacramento, California, although it's a fairly large city, it's much smaller than the United States. But even so, it would be very expensive and time consuming to actually survey every household with one or more children under the age of 18. So what we're really trying to do when we're doing a survey is we're drawing a sample from the population so that we can get some type of statistic that will allow us to make inferences about the population. We want to be able to say 25% of the population in Sacramento, California with one or more children under the age of 18 living in that household view the educational system in Sacramento to be favorable. And we might be able to do that by interviewing 100 or 200 households from a sample of households from the entire population. But we draw that sample from the population, and then that allows us to infer certain things about the population from the sample. We wouldn't interview households in North Carolina with one or more children under the age of 18 to get information about the Sacramento school system. That wouldn't make sense. We couldn't do that. So we wouldn't be really defining a very good target population. But if we went to Sacramento and divided it up by districts and took so many households from each district in that county or in that city, that might be good enough to infer, to use those statistics to infer, to make inferences about the population. The next step is identifying the sampling frame. Once we've defined that population from step one, we have to figure out, if we're not going to interview every single person or every single element in that population, which again is probably going to be impossible time-wise and money-wise, then we have to identify some type of sampling frame. In other words, we have to find out, how can we identify people to put in the sample? Now, we could do this from databases, telephone directories, although that may not be a good way these days to do it because the telephone directories are outdated. Lists developed by certain companies that will give us this type of database. So a sampling frame is simply, where do we get the information? How do we know where these households are? How do we know the addresses or the telephone numbers? Where do we get this so that then we can go find them and ask the questions? The next step is selecting a sampling procedure. So before we select a sampling procedure, we really need to know the difference between a non-probability sample and a probability sample. And it's quite simple. A non-probability sample does not allow us to use statistics from the sample and make inferences about the population, because the sample subjects that we are interviewing are not randomly chosen. So there's neither a sampling error nor a margin of sampling error can be estimated or calculated. So there's no way that we can say with confidence, with 95% confidence, we can say from our survey that this is true of the entire population. We can't do that with a non-probability sample. Some of the techniques include, and we'll go over them, convenience samples, judgment samples, quota samples. Basically what it's saying, and we're going to go over this, these are not randomly chosen. Whereas a probability sample is where each, the sample in which each target population element or each person in that that population has a equal chance of being chosen to be surveyed. So if we were doing a probability sample of Sacramento, California, again, to do those interviews about the educational system, everyone in that target population, Sacramento, California, with one or more children under the age of 18, has an equal chance of being chosen for the survey. Okay, and these are simple random samples, systematic, stratified, and cluster. Now, I want you to know the difference between non-probability and probability. I also want you to know the techniques that are non-probability and the techniques that are probability. One thing I do want to make clear here is that even though it's, as I've described so far, it would seem, oh yeah, we definitely want a probability sample. Sometimes even that is not possible because of time and effort and financial reasons, where we may just conduct a simple convenience sample that, you know, we just, for our own purposes, we want to know something, but we won't be able to infer it to the entire population because it's non-probability. So a convenience sample, and again, this is a non-probability technique, is just as it is described. It's for our own convenience. So if, let's say for in the effort of saving time, we go out and we want to question, we want to pose a question to some people on campus, and we position ourselves between the Falcon Center, or right outside the Falcon Center. And every time someone walks out of the Falcon Center door, we ask them the question. That's a convenience sample because we're standing there and the people are coming by to us. We can ask the question. The reason it's non-probability is some people on campus don't visit the Falcon Center every day. Some people on campus never visit the Falcon Center. Some people aren't even on campus. Some students don't come to campus. Some students only take online classes. So if we were interviewing students, not every student would have the same chance of being interviewed if we only positioned ourselves in one place on campus for our own convenience. And so one of the examples it gives here is television news question of the day. You probably never even heard of that, but years ago the television local news and national news would just go out on the street and interview people. But they just go right out of the street from the studios and ask these questions. Well, if you weren't outside the studios that day, you had no chance of being interviewed. Obviously, it's a non-probability technique. Judgmental samples, another non-probability technique. So a judgment sample may be one where we actually select an expert in the field of whatever we're trying to figure out or whatever information we're trying to get. So the example here is a really good example. Hire panelists who are knowledgeable about the issue being researched rather than selecting them at random. We're using our own judgment. So it's still a non-probability technique if we're choosing that person. Another non-probability technique that is sort of the same judgment type sample is snowball sample. And this is where you would actually ask, let's say you ask your friends, you wanted to ask your friends a certain question for school. And then once you ask the question, you would ask them is there someone else that I can ask? Do you know someone else that I might be able to survey? Well, obviously, they're probably going to refer you to a friend of theirs, someone who's in the same age bracket, same income bracket. So it snowballs because you start getting the same type of people from these referrals, and you don't get a wide range of different people. Again, that's what makes it non-probability. Quota sample, again, another non-probability technique. And in the essence of time, I'm not going to read this word for word, so you can take a look at quota sample, and it's fairly simple and self-explanatory in the text on the slide. This is just another example of a quota sample where you take the quota from the composition of the population here, talking about freshmen, sophomores, juniors, and seniors, and so forth. A simple random sample is a probability technique. So this is a probability sample where everyone really has the same type or the same chance of being selected. And a lot of times this could be drawn from a computer or a physical list using a random number table where everyone really has the same chance of being selected, and they're just chosen at random. So when someone that you're going to survey is chosen at random to be surveyed, then everyone has the same chance, and that's why it's a probability technique. Systematic. Again, I'm not going to go through this word for word. You can see this or read this and study it. Stratified. These are all probability techniques. And cluster. This is sort of a review that shows the difference between non-probability and probability, which I covered for you earlier in the slide presentation. Determining the sample size, step 4. So remember this when you're trying to determine the sample size. In other words, how many people are we going to interview in order to get accurate information about the population, if it's going to be a probability sample. And the size of the population really doesn't have any bearing on this. What drives or determines the sample size are these factors. The amount of diversity or variation. So if we want a lot of diversity and variation in our sample, as that increases, then we're going to need a larger sample size. So if we want to interview a certain group of people, and the only diversity that we're going to put in there is we want men and women. We don't care about their age. We don't care about their ethnicity. We don't care about their religion. We don't care about their race. Then the sample size would be probably fairly small. We say, well, we're going to interview 10 people, five men, 5 women. But as we increase the diversity and the variation of what we're looking for, that's when the size of the sample would get larger. Degree of precision. How precise do we want to be with these statistics? Do we want these statistics to really hone in on what the population represents? If we want that if we want that precision to be very tight, then we're going to have a larger sample. We can't interview 2 people and think that those statistics are going to be very precise to the population. So if we want that information to be very precise, then we're going to have a larger sample. The same thing with confidence. If we want to have a very high level of confidence that what the statistics say the same thing about the population, then that's going to mean a larger sample size. So if we want to say with 99.9% confidence, the poll about the election is very accurate to the population, 99.9% confidence, you would have to almost interview the entire population to be that confident. So obviously at any given sample size, there's trade-offs between confidence and precision. Higher precision, can't say that word tonight. That's because it's 10:30 and it's past my bedtime. Higher precision means lower confidence unless we can increase the sample size. Okay? So if we get really precise, unless we increase the sample size, then there's going to be lower confidence in those answers. So as I said earlier, the size of the population really has no bearing on the size of the sample. It's all about variation, precision, and confidence. That's what drives the sample size. And I've talked all along about considerations. Cost, time, available research budget, all these things are considerations that we have to look at. Type of analysis, past research that's been done. Step 5 and step 6, as you'll see in your book, are selecting the sample elements, where we're asking them, and then collecting the data. And these the author's slides don't go into detail about those, which obviously, but you can see that from the chapters. So that's chapter 9 in a nutshell. Again, I hope you're staying safe, enjoying your summer, and take care, and I'll talk to you in the next chapter.